Okay, welcome to another Train the Trainer video. This one is looking at a more complicated app, and this app is a wobble table, which means it's an app that looks at the accelerometer and it measures the accelerometer, and it then comes up with some measurement of how much the device, the phone, the tablet or whatever, has wobbled in the time that it's been running. So the cool thing about accelerometer games is that they emphasise what's different and what's interesting about developing for mobile. And I think this is probably the most important part of this. If the thing about a mobile phone is that it's a physical computer. You interact with it in different ways than you do with an ordinary desktop or laptop computer, and it affords new forms of interaction. Not just the whole touchscreen multi-touch interface, but also interaction to do with location, interaction to do with the way that device is actually moving in space. And this is a really interesting and very straightforward way of interacting with the human via the way the device is moving. So it's a very mobile activity. A lot of the other things that you do with App Inventor are going to be more analogous to basic computing, press a button, make a noise kind of stuff. This really takes it into the realm of the mobile. The second reason why this is an important app to do is that if you, the trainers, build this app, you get a side activity that will help you to fill any dead time during the day. I use this app as a kind of background activity. So I set up a very simple obstacle course, just some chairs for people to weave in and out of. If there's a stage, step up onto the stage and so on. And you get the attendees to take it in turns to take your own phone with the app on it around the arena and then record their time on a piece of paper and not record the time, record the amount of wobble on a piece of paper. And it's a means of testing who's got the steadiest hand in a sense, but it's also a means of getting them to interact with an app that's been made with the software that they're using on the day. And it can help fill any dead time during the day, and it gives the kids a chance to move around, and there's all sorts of other reasons for doing it like that. And the third reason, which is also quite important, is that it gives you, the trainers on this particular App Inventor adventure, some experience in dealing with a really complex App Inventor project. It's not really complex, but it's probably going to end up more complex than anything that the attendees will be doing during the day. So this is getting you used to coding App Inventor and getting you used to doing it. So what I'm going to do is I'm going to go through this, and we're going to look at the code that I've written so far, and as part of this video I'm going to modify that code to make some changes. So looking at the code, let's go to this window. Here we have the code. So this is the code. In the designer, what we've got is we've got the standard window of the App Inventor interface, and on that we've got three buttons: start, stop, reset, start button, stop button, reset button. And if we scroll down, there's accelerometer sensor 1, which is a non-visible component, and there's also three text boxes, 1, 2, 3, called X, Y and Z. And then if we look at the blocks, what we've got is we've got a set here, which is a kind of set of initialization blocks. I've just put these in the same place just so they're easier to spot. Then I've got a couple here. When start button dot click, set global running to true. When stop button dot click, set global running to false. What these are doing is these are controlling the flow of the program. So if we look in the designer, we've got a start button and we've got a stop button. And here we've got start button, stop button, and this is what they're doing. There's a global variable called running, which starts off in false and only becomes true when the start button is clicked. So let us now look at the meat of the program. If we scroll down, here we've got the meat of the program. This says when accelerometer sensor 1 dot acceleration changed. So this is whenever there's a movement. First off, we're going to check to see if the global running is true. And what this says is we're not going to do anything unless it's running. Yeah? Because unless the global variable which we've called running is true, none of this is going to execute. And that's how the start-stop buttons end up as being like on-off switches. If it is running, these global variables we've got up here, xv, yv and zv, are going to be set to their current value plus the acceleration. And this has the effect of incrementing the variables to deal with acceleration in x, y and z with the value of acceleration in x, y and z. So the more it accelerates, the more they're going to go up. So that's that. Having looked at it there, what we're going to do, we're going to see what that looks like on the actual laptop, on the actual mobile device. So we're going to package QR code, and I'm going to load that onto my device, and then so what I've got is I've got a start, a stop and a reset. So I'm going to press start, and you see what we've got quite a lot of numbers, and they're going up quite fast, and they're changing all the time. Wow, how's that happening? How's that happening? Anyway, we'll click the stop button. They're basically going up as the phone moves. So let us go back and see what we can do about that. What we want is a reset button. So at the moment there's a reset button and it doesn't do anything. The other thing we want is one wobble score. So instead of having X, Y and Z going up all the time the phone moves like a hair, what we want is one score that does one decent thing, and it's a measure of how much it's wobbled. The options for this include taking just one of the components, so we could say that it was just X, Y or Z, or we could use some combination of the components, so we could do X plus Y plus Z if we wanted. And the next thing we want the wobble score to somehow look reasonable. So we don't want it to be 5 decimal places. We might want to have some text saying you have wobbled this much, that kind of thing. Anyway, so let's go back to App Inventor. And first up, we're going to give it a reset button. You'll notice from the designer that I'd already started this. We've got a reset button here, which is called reset button. So if we go to blocks, we can make reset button do something. So the first thing I'm going to show you, which you might hopefully find useful, is you don't have to navigate around in all of the windows. So if you want to find out what to do reset button, you can click on reset button and there's loads of stuff there. But if you're a proper coder, you can just type when reset button and then it auto completes with .click. And you can do things. So what do we want to do when reset button gets clicked? Well, first off, we want to stop it running. So we'll do set global running to click again false. That gives us that, and we can put that in there. Put that in there. So now we've got a reset button which does exactly the same as a stop button. But we don't want that. We want something that's a bit more obvious. So we want to take the global variables xv, yv and zv all to be 0. So set global xv to 0. This being able to tick, just click on the background, type a number. Doesn't always work perfectly, so you might have to try it a couple of times, but when it works it's great. It means you don't have to remember where things are in the menus, you just have to type them. So if you can remember what they are but you can't remember where they are, it works magically. So we're going to do set global zv to 0 again. 0. Yay. Don't know why I had to do that 3 times. Sometimes it just happens like that. And that's cool. That's cool. My reset button stops it and it zeros everything. But actually we also want the text to be 0 as well. So I'm going to just copy that block. And copy that block. Copy that block. I'm using Control-C, Control-V for my copying, for those of you who are interested in keyboard shortcuts. So when the reset button's clicked, we're going to stop it running, and we're going to set XV, YV and ZV to 0, and then we're going to update the text values of all of these to match what we've just set them to. So reset button will stop it running and set everything to 0. So let's build that and have a look and see what it looks like. Installing. Installed, open. Right, so now we've got a start button, a stop button, a reset button as before, but now the reset button should do something. So start. Started it. It's going. Stop. Stops. Start carries on from where we were. Can I press reset and what reset? So we reset, reset. Oh, it's all zeros. And it stopped. And brilliant. So start. Reset. Oh, reset. Excellent. So that's good. We've got a reset button. Back to the thing for more live coding. Woohoo! So here we are again, back at our app inventor. And what I want to do now is I want to give us sensible values, yeah? So at the moment, we've got XV, YV and ZV being pretty much exactly what comes out of the accelerometer. And if you look at the documentation for the accelerometer, there are a couple of things you learn about it. Firstly, it's got a sensitivity. So if we look in the accelerometer sensor options, you can do things like set accelerometer sensor things to things. Yeah, so we're going to set the accelerometer sensor sensitivity to 1. And what that does is it says we don't need it to be that sensitive. We're going to set it to its least sensitivity. We don't need masses of precision here. The second thing you learn is that when you leave the thing flat on the table, the device flat on the table, the X should be near 0, Y should be near 0, and Z should be fairly near 9.81, because that's the acceleration due to gravity. So what we're going to do is we're going to take 9.81 away from Z. Yeah? And if you look under math, there's a minus box, yeah? There's a minus box. We'll have a minus box, yeah? And we're going to take 9.81 away from ZXL. Okay? So we're always going to take 9.81 away from the Z acceleration before we do anything. So that's going to make the Z not quite so mental. The next thing you realise if you look at the accelerometer stuff is that actually some of it's negative. Yeah? So if you move up, then you get a negative acceleration. Or if you move right, then you get a negative acceleration. What we're interested in is just like a wobble. So what we're going to do is we're going to take the absolute value of all of the things we're dealing with. So we'll go to math. And if we scroll down on the math options, absolute is one of the things we can do. So we can drag the absolute across and we can put it there, and that should just work. And we can do that again, absolute. Ping, bum, ba-da, ba-da, ping. So what we've got here should be a less noisy measure of acceleration. And it's going to be absolute values rather than lots of decimal places, and the Z value is not going to change 10 times faster than all the others because we're now taking gravity into account. So let us build that app again and see what happens. Yeah, I've got the new app, I've installed it. Hopefully this is the new version. And what we're finding here is that what we're getting is that we're getting absolute values, so it's only going up. The Z one doesn't go up as quickly as the others. One of the things that you can find out if you put it on the table is, you can't see that, I don't know, let me do something, man. Here we are, I'm moving my laptop so that the webcam on my laptop points at my phone on the table. Is that working? It's hard to say. This is really bad cinematography. Anyway, this is what it does when it's flat, yeah? It's not moving so much, but it's still moving quite a bit. Stop. So, we've got an app which is kind of getting better, yeah? Again, this is incremental development, this is coding on the fly. This is me trying to think of what's going to make this app better as we go along. So the fact that it's not perfect just shows that it's just part of the development process. And you should all be pleased with that anyway. So let me think about what next. Next we want to take it, say we've got an actual wobble value, right? So we go back to the designer. We're going to have an actual label, and that label is going to be our wobble label, and we're going to put it there. We don't need text on it, so we'll start it off with a 0, which is reasonable. We don't want to call it label 1 because label 1 is a silly name for a variable, so we're going to rename that wobble. Wobble. Wobble value. No, wobble label. Wobble label. Okay. So now we've got a wobble label. Wobble label. Anyway, black at the blocks. This is going to be our total wobble value. So we're going to have a global. Initialize global wobble to 0. So we're going to start it off at 0 as you would expect. Yeah, we're going to want to deal with it over here at the same time. So we're going to have global wobble is going to be 0'd when we reset. We're going to update the text when we reset. I'm just doing this as I go along because it's useful to think about these things as we go along. So we're going to need to change the text down here. Again, when I'm just duplicating stuff, I'm just doing Control-C, Control-V. Yeah? Excuse me. So now, this is going to be our wobble function. So we're going to global wobble. Yeah? And what are we going to set it to? Well, we're not going to set it to that, for starters. What we want is we want something that is a measure of overall wobbliness, but we don't want it to be too big, yeah? So what we're going to do is we're going to add up X, Y, and Z. Yeah? And then we're going to divide it by 10, and then we're going to make it an integer. So first up, we want to add X, Y, and Z, and we've only got 2 holes in our add thing. This is where mutable blocks are brilliant. See this symbol here? Looks a little bit like a cog. You click on that, what you can do is you can change the number of things that a function will take as its argument. So that enables us to add 3 numbers instead of 2. Isn't that neat? And we're going to put in there, I just managed to make myself a block just off the bottom of the screen. We're going to put in there X, Y, and Z. So that's the sum of X, Y, and Z. But we don't just want a sum because that's just going to be a massive number. We want this to be a fairly small number, don't we? So what we'll do is we'll take that and we'll divide it by, I don't know, 100. This is me guessing. We'll divide that by 100. So we'll take that and we'll divide that by 100. And we'll put that in there. What do you think? I think that might be alright. I think that's probably going to be a number with lots of decimal places. I don't like numbers with lots of decimal places. We're going to get rid of the decimal places by using floor. We can put floor in there, and that says, right, the global wobble is going to be X plus Y plus Z divided by 100, and then we're going to throw away any decimal bits and just keep the floor of that number, so whatever it is, floored. So let me think about this. So what we've done, we've added it to the reset block, the wobble label and wobble. We've initialized it at the top, initializes there, okay. And we look down here, we're setting it to something sensible, we're updating wobble label.text to be the right thing. In my view, I think we might have got that, so I'm going to build that, And we're going to put it on the phone, and we're going to see what that actually looks like on the phone. So we've got 4 numbers, start, stop, reset. The top one should be our wobble thing. And for some reason that doesn't look quite right to me. That looks much bigger than I was expecting because of the whole divide by 100 thing. So let's go back to the code and see if we can work out what I've done wrong. It also should be not like loads of decimal places, because in fact it looks to me, it's very much to me like that's the Z value. Does that look like the Z value to you? Let's go back and see what we've done. Reset. Never do live coding, that's what I say. But you could I've spotted it. I've spotted my bug. It was here. Right, now let's build it again. So, I'm reinstalling it again. I think I've spotted both of my bugs this time. Proves that nobody's perfect, eh? Right, it's installed. There we go. Start, stop, reset. Start. Now, the wobble is a much smaller number. And if you move the phone a lot, it goes up a lot quicker. It's possible to keep it quite low. Very difficult to get it to stop altogether. But it's possible to get it quite low. And that's kind of the point. So, having done that, what we've got now is we've got a system where the app will add up how much the phone has moved in a very rough sense, and it enables you to check that the phone works, check that the acceleration is measured. It enables you to talk about acceleration, even enables you to talk about gravity if you want to. For us, that's enough for the App Inventor day. Having an app where someone can press start, walk around the room, press stop, and they can have a competition to see who gets the lowest score for walking around the room. That's kind of what we're at. That's good enough. It's like a bit of a game, but it's not quite finished. You could think about making it into an actual game though. So if you wanted to say have a basket of eggs, and when the wobble goes up by 10, one of the eggs will crack, that's something you could do. You could have a high score table. You could have the sensitivity go up, so you have levels of difficulty and so on. And you could end up with something that looked a bit more like a game. And that's the kind of thing that people have been who do App Inventor with a little bit more time on their hands actually get around to making. So that's my very quick bit of live coding there, looking at making a game which takes the accelerometer and does something vaguely interesting with it. Hopefully that's useful, and hopefully you'll be able to do that. What I'm going to do as part of the Train the Trainer session is the starting point. So the game that didn't have the reset button, didn't have the maths in it, is going to go up as an App Inventor application for you to download and install on your own, and have a go at following along with this video yourselves. I'll also put the finished product up in case any of you fancy cheating, but I wouldn't. It's worth having a go at doing it yourselves, and that's the end of that. Okay.